So till now we have understood what is device driver and what is the role of device driver. So now in this session we will understand what are the basic component of a device driver. Like when you are writing a device driver, what are the basic things you need to implement in a device driver? So in a basic device driver, we have to write at least two things. First is init and exit calls, and second is the FOB structure, which is called file operation structure. And third thing is which is interrupt routine. This is optional thing. Interrupt routine is like for handling the interrupt. If your device is basically handling an interrupt, then you have to write this interrupt routine so that whenever your device will get an interrupt, so this particular interrupt routine will be trigger and handle the interrupt. So now let's understand one by one what is the init and exit calls, what is the FOB structure, and what is the interrupt routine. So as you have discussed in now, like a device driver is a piece of code which lies in the Linux kernel, and it provide a way of interaction of user space application to the kernel, and then kernel will interact with the driver, and then driver will interact with the device, and vice versa. So whenever a device is present in the system and you have written a driver for that particular device, so you have to tell to the Linux kernel which is running into that particular system or the device. You have to tell to the Linux kernel, okay, I am the driver of this particular device and I am present, so hook myself into your database. By hooking up of device driver means kernel will have info now onward, like for this particular device, if some request comes, so you have to use this particular driver. This is what happens when you connect a USB device to your system. So the first thing happen is device driver is installed. Okay, and after installation of device driver only you will be able to access that particular USB disk or drive connected to the system. So init calls present in the device driver call, which actually does the task of informing kernel or requesting kernel hook myself into your database, or hook myself in or register myself in the kernel, so that whenever there will be any request for accessing my device, you please let me know. In a layman terms I am telling you all this so that you will be able to understand in an easy way. Besides notifying or registering with the kernel, it also allocate any kernel memory required for the device, and it also initialize the hardware. These are the basic things it does. And now init function, basically init function of the device driver can be called at a boot time if this is an inbuilt module of Linux kernel, or this can also be called at a runtime if this driver is developed as a module. So at a runtime, whenever you will be install that device into the system, init function of that particular driver will get called. You can take example of whenever you are inserting the USB disk in the system. So device driver only get installed whenever you are inserting the disk into the system. So init function of your device USB device driver will get called at the time whenever you are connecting the device into the system. And there is much more info which we need to learn. We will discuss in some other session, like how the device is being detected into the system and how the device driver is installed. But for now, you just understand init call or the init function present into the device driver, which basically register device or driver with the kernel and allocate the kernel memory if needed by the device. And with that, it initialize the hardware if it has to do any basic initialization of the hardware. In the same way, whenever our system is being shut down or the device which you connected is going to be detached from the system, because if the device was installed at the runtime when you connected the device to a system, so you install the device there for that respective device. In the same way, whenever you will eject that device, whenever you will eject the USB device from your Linux machine or the embedded devices, so you need to unregister yourself with the Linux kernel, which is does which is done by exit system call, or we can say the exit call of your driver. What it will do is it will first register itself with the Linux kernel. With that, if it has allocated any resources during the init time of or the during the init call, it has to free all the resources whatever it has allocated at the time of init call. So these are the basic calls, init and exit calls, and the purpose I just explained. Now, this is a simple hello driver written. At this point of time, you might not be able to understand this piece of code, but don't worry, in the next coming session, we will be writing the same piece of code and we will be executing this same piece of code in our machine. So this is a basic hello driver. In this, you can see two function. First function is hello init function. Another function is hello exit function. Now, how Linux kernel will know that this is the init function of this particular driver and this is the exit function of this particular driver. So there are certain macros or the functions which is provided by Linux kernel. You have to call that macro or the function, and in that macro or function you have to pass function name of init and exit call, so that kernel can get to know, okay, so these are the init and exit call of this particular driver. So whenever your Linux kernel boots, it will call the init function, and whenever it will go to shut down, it will call the exit function of your driver. So here you can see you have two function. One is init function, other is exit function. In the init function, you are doing nothing but printing hello world. Now you might feel, what is this print k? So print k is nothing but if you have to print any log in the system. So in the kernel, basically, we use print k instead of printf that we used to use in user space program. When you are writing a C program in the user space, we mostly use printf for printing the stuff. So here in the Linux kernel, we have same kind of function call which we use to print any message into the logs. So print k, it's a kernel print. So you can see here, with that we use kernel alert. So these are the different flags we use: kernel alert, and with that other flag also we have. Kernel alert is means like it's a kernel alert, so we have to print this message into the logs. So we will discuss about different level of print k in the next session, and then we are returning 0. 0 means success. Then we have hello exit function. In hello exit function, basically we have printing goodbye, which will be printing into the logs and which will notify, okay, so this driver is already unloaded. So now we have module init and module exit function. By using the module init function, we are telling the Linux kernel, hello init is my init function. And by using the module exit function and passing hello exit function as an argument, we are telling the Linux kernel, this is my exit function. So whenever Linux kernel boots, and I'm assuming this driver is basically compiled as an inbuilt driver of Linux kernel. If you're not able to understand what is inbuilt driver or what is the module, so don't worry, we will discuss the same in the coming sessions. So I'm assuming this is as a inbuilt driver. So whenever Linux kernel boot, it will call init function of each of the inbuilt drivers. So it will call hello init, and we would be able to see hello world in the logs. And then we have static void hello exit. So whenever our system will go for shutdown, it will call exit function of each of the driver. So for this driver, hello exit function will get called and we will printing goodbye in the logs. So this was all about init and exit calls. So now let's understand FOP structures or file operation structure. So now you understand whatever the device driver just I shown to you, that is was like a virtual driver, because there is no actual hello devices present into the system. I have just written a driver just to print the log message hi and hello. But whenever you have to write the driver for a particular device, so that device will be performing some functions or some task it will be performing, and that task will be, or that function will be used by user space application. Now let's take example of USB disk. So a USB disk has to perform different operations. First operation is read. You should give reading access to the user so that user can see the data present in the USB device. And the second thing is write. So write function means it will provide the capability to the user to write some data into the device. And the third thing is you have open. So open call is like used to open the device connected into the system. And then you have release. Release function will be used for releasing the device. It means ejecting the device from the system. You can say in that way. So you have to specify, like these all are the capability this particular device is going to expose to the user. How we will do that? You will specify all the functionality of that particular device in the file operation structure. So here you can see we have one structure of type file operations. File operations is the structure type which is provided by Linux kernel. So here we have given the name FOPS. So in that we are basically, for just assuming our device will be supporting only four functions. One is read, other is write, and then open, and then release. Okay. So this read, write, open, and release, these all are function pointers. And these function pointer will be initialized with the respective functions of my device driver. So now let's say the function which support read of my device, I have given the name of that function is dev underscore read. The function which support write functionality of my device, I given the name dev underscore write. And then I have, for open, I have written a dev underscore open function. And then for releasing, I have written a dev underscore release function. Okay. So now you can understand these things. For opening, reading, writing, releasing, I can give my own names in the device driver. Dev underscore read, dev underscore write, or basically xyz underscore read, xyz underscore write, or whatever. But user doesn't know, right? Like what is the name given to the open, read, write, and all. If so, then user has to remember, okay, to access the USB device, I have to call my underscore read function. Then for opening the camera, I have to read camera underscore something something. It will be a pain. Nobody can remember all these names. So to avoid that, Linux kernel has a virtual file system concept in which virtual file system expose a basic system calls like open, read and write. User has to only call open and then they have to tell for this device I am calling an open function call, and for this particular device I am asking write function to call. So now virtual file system will forward that request of reading, writing or opening or releasing to the respective device. But how Linux kernel will know, like for reading this particular device it has to call this function, or for writing this particular device I have to call this function. So this is the mapping which basically tells the Linux kernel, if a read calls come for my device, call my dev read function. If a write call comes for my device, call a dev underscore write function. If a open call come for my device, call dev underscore open function. If a release call come for my device, just call a dev underscore release function. So to understand these in details, you can go through our Linux kernel training in which I have discussed a system call in a one chapter or a one session where basically you can read all these things in a detail. So file operation is the way of telling the kernel, okay, so these are the capability I am going to support and you have to call these all are functionality for so and so functions. Now, as I said, if your device is having interrupt handling capability, so you have to implement an interrupt handler in your Linux kernel or in the Linux device driver code so that whenever interrupt will come for your device, so Linux kernel will call your interrupt handler, and in interrupt handler you will be performing certain desired operations which you need to perform at the time of receiving interrupt. So in the driver, first you have to tell the Linux kernel, if this particular interrupt comes for my device, you have to call this particular handler of my driver. So there is a kernel call which is request underscore IRQ. This function is used by device drivers to tell Linux kernel, for this particular interrupt, please call this particular handler. So this takes so many argument that we'll discuss later. So this is an example of an interrupt handler. You can see here RQ return T. RQ return T is the IRQ return type. IRQ handler is nothing but an interrupt handler, and it takes these arguments. And in that, what I am doing, for just to give you an example, what we are doing is we are just printing the message, hi, I am handling interrupt, and then we are just returning it like IRQ handle. So IRQ handle means we have handled the interrupt. So that's all for from this session. I hope now you are clear about what is init call, what is exit call, what is file operation structures, and if my device is handling an interrupt, what calls I have to use. Thank you. Thanks for listening.